Jai Shri Ram friends, today we shall start laws of motion. This is part 1. In this particular video, I shall discuss about the basic terms. Number one is force, which contains inertia and momentum. Then we shall discuss about Newton's law of motion, which means first law of motion, second law of motion, and then resultant force. What is resultant force? Then we shall discuss about impulse, and finally Newton's third law of motion. That is followed by the third part, which is law of conservation of linear momentum. Then we shall discuss about forces in equilibrium, means Newton's first law for forces in equilibrium. And finally, in this video, we shall discuss about common forces in mechanics, that is free body diagram we shall discuss. Besides this, I shall discuss some tough numerical drill problems which are very important regarding your NEET examination. Okay, so this would be your knowledge blaster. Okay, just see this video with great patience. I firmly believe that you will be getting a lot of knowledge from this video. So let us start this video. Okay, now what is force? First of all, I'm just writing down simple definitions. This is just for sake. Okay, gradually we shall increase the level of the discussion. For example, what is force? The force is nothing but an effort in the form of push or pull causing or tending to cause motion, means change in the motion or deformation in a body. Fine. Now there are different types of forces. Number one, which is distant forces, or also known as field forces, and other is contact forces. Distant forces means act without physical contact, right? Second means, example, you can say gravitational force, electrostatic force, or nuclear force, or in case of the human body it could be a weight also. Similarly, contact forces are those forces which require direct contact between the objects. For example, friction, you can say normal reaction, tension, a spring force, etc. So these are certain examples. Okay, now next is inertia. What is inertia? So inertia is nothing but the resistance of a body to change its state of rest or uniform motion. Means it's the natural tendency of the objects to keep doing what they are doing, right? Whether staying still or moving. So it was first introduced by the scientist Galileo. Now there are three different types of inertia, as you can see here. Number one is inertia of rest, means body at rest stays at rest unless acted upon. Second is inertia of motion, means body remains in motion, means uniform motion unless an external force changes it. And finally, we are having the inertia of direction, means the body cannot change its direction of motion on its own. So this is about inertia. Okay, next important term is momentum. What is momentum? Momentum of a body is the quantity of motion possessed by the moving body. Means it is measured as the product of the mass and velocity. Means you can say momentum P is equal to mass into velocity. Means the unit SI unit is kilogram into meter per second, or you can say CGS unit of the momentum is gram centimeters per second. Okay, and this is the dimension, which is MLT minus 1. It's the vector quantity. So this is just a basic knowledge. Okay, so we will be increasing the gradually the level of this discussion. Now come to Newton's law of motion. What is Newton's law of motion? So there are basically three laws of motion which are introduced by Sir Isaac Newton, as we already know. So first is Newton's first law of motion, law of inertia. This is also known as law of inertia. Means it says that every body continues in its state of rest or uniform motion in a straight line unless acted upon by its external force. Means if the net force is 0, then acceleration is 0. Okay, in the absence of force, any force, the acceleration remains 0. Second is motion or rest will not change on its own due to inertia of body. And another important thing, that this law defines force qualitatively. This is one thing which you should remember. Okay. Next is Newton's second law. What is second law? Rate of change of momentum is directly proportional to the applied external force and takes place in the direction of force. Means formula is F is equal to m into a, where m is the mass of the body in kilograms and a is the acceleration of the body in meter per second square. And then force is measured in Newton. So you see this one, force is mass into acceleration, and this law defines the force quantitatively. So this is the difference among the two forces. One is first law and the other is second law. Okay, then force causes acceleration in the direction of the applied force. Okay, for example, you can take the example of an aeroplane in which the acceleration forward direction, force is acting in the same direction, means F is equal to m into a. So force, mass and accelerations are related for Newton's second law. I think you get it. Okay, next is how to calculate the force using Newton's second law. Okay, so this is a little discussion about the same thing. Means let a body mass m changes velocity from v to v plus delta v in time delta t. Okay, then the change in momentum would be delta p is equal to m into delta v. This is a simple basic thing we should know. Then Newton's second law, which is the mathematical form, so means F is proportional to delta p upon delta t, as we can see here, or you can say F is equal to k into delta p upon delta t. This is constant of proportionality. Okay, then taking the limit delta t tends to 0, means very small time, which is infinitesimally small time, delta t. Okay, then F is equal to k times dt of v, means this is a differential, first derivative. This is the first derivative. Okay, this is meant for delta t tends to 0. If the time interval is very small, then this becomes the first derivative, means differential form. For constant mass, you can say F is equal to k dt of m into v. Okay, so as we know, for a constant mass would be taken out of differential, and you can say F is equal to k into m times d dt of v, means F is equal to k into m into a, because a is nothing but the acceleration, which is rate of change of velocity, as we can see here. Okay, next, if velocity is fixed and mass is changing, then what happens? Then in that case, F is equal to v dm upon dt, because F is equal to m into dv upon dt. Okay, then if m is changing, then v velocity is supposed to be constant. It means velocity is taken out of derivative and mass is differentiated with respect to time. So this is in case of mass is changing. Okay, so conclusion is that final formula is F is equal to m into a, and force is the vector quantity. It has both magnitude and direction. So we should remember this thing. Okay, next is what is the relation between Newton and dyne? Dyne is basically CGS unit of force, and Newton is SI unit. So 1 Newton is equal to, you should remember simple, 1 Newton is equal to 10 raised to power 5 dyne. Okay, so there is nothing special about this. You should remember this expression only. That's it. Now let us proceed. What is the resolution? Means how to break or decompose the force into different components. For example, if there is a force applied on a particular body and this force is having all the three directions. For example, if F is equal to Fxi, Fyj plus Fzk, means force components are all in three directions, in ijk direction, and acceleration is also in all the three directions. So I am saying just if the force applied imparts acceleration A to a body, then its components in x, y, z directions are basically this acceleration. Okay, component force will be like this, Fx, Fy, and Z. So F is equal to ma expression. You are just putting these two expressions in this, then you are getting like this, Fxi cap plus Fyj plus F2k is equal to m times Axi plus Ayj plus A2k, right? So if you are comparing the coefficients of I, j, k, n on both sides, you are getting Fx is equal to m into x, which is m into d dt of Vx is equal to m d2 x upon dt square, or you can say simply d dt of Px. Similarly, Fy is equal to d dt of Py, and Fz is equal to d dt of Pz. So means you can say there are three components which are just nothing but the rate of change of the corresponding moments in the respective direction. Okay. Now what is resultant force? So when two or more forces act on a body simultaneously, then the single force which produces the same effect as produced by all the forces acting together is known as the resultant force. For example, if this is a body, there is a mass, and there are four forces acting simultaneously on this as per the direction. Means the three forces are moving outwards, and all four forces are moving outward. Then resultant force is just the summation of all these forces. Means F is equal to F1 plus F2 plus F3 plus F4, because all the directions are same with respect to the body. So this is the resultant force. Now what is impulse? There is another concept of impulse. Impulse, what is impulse? Basically, this is a force which is a very large force acting on a body for a very short interval of time. So when a large force acts on a body for a very short time, the product of average force and time is called the impulse. That's it. Okay, so it's a force, but for a very large amount of force for a small time. So impulse would be average force into time, means F into delta t, or you can say F in I is equal to integral t1 to t2 f dt. Okay, impulse is a vector quantity. We can say its direction is same as force, and dimensional expression is mlt minus 1, same as momentum, or this SI unit is Newton into second, or you can say kilogram meter per second. CGS unit is gram centimeter per second. So these are basic points regarding impulse. Okay, how to understand this impulse. Okay, now next is relation between momentum and impulse. Now see, this is another important thing. Let F be the force acting on a body and P be momentum. Okay, F is the force and P is the momentum. Then Newton's second law says that F is equal to d dt of P. You can say so F into dt is equal to dp, as we can understand here. Okay, so this is simple thing. Now if this force acts for a short time t, the momentum changes from P1 to Pt. Then integrate. If you are integrating both sides, you are getting integral 0 to t ft is again P1 to P2, because we are changing the limit for dp, or this becomes P2 minus P1. So finally we can say integral 0 to t f dt is equal to simple P2 minus P1, means this is final final momentum, and this is initial momentum, you can say. So if you are taking the difference of the two, you are getting the impulse. Okay, so this is the relation between momentum and impulse. Okay, now what is the key takeaway from this discussion? Just I have discussed all these points. This is the key result, means impulse is change in momentum. That's it. So I is equal to F average into T, which is P2 minus P1, or you can say delta P. So this is known as impulse momentum theorem. So this is very important regarding your NEET examination. What is impulse momentum theorem? So this is nothing but impulse is equal to change in momentum. So these two are related. So summary points you can say here. See this. I am just giving the summary points. First one is impulse is nothing but integration of force into time, and it could be average force, you can say, and then impulse is area under force time graph. तो ये आपका force time graph के बीच में जो area होता है वो force time graph होता है. Okay, and impulse is the vector, and unit just I told you, just Newton is Newton second, or you can say kilogram meter per second. And this theorem is called impulse is equal to change in momentum. This is called impulse momentum theorem. Okay, now see what is Newton's third law of motion, which is third law. Statement is to every action there is always an equal and opposite reaction. That's simple. Okay, one line statement. So this means whenever one body exerts a force action on another body, the second body simultaneously exerts the same force reaction on the first body. As you can see here, there are two objects, object 1 and object 2, and this object 1 is exerting force F12 on object 2. Similarly, object 2 would be reflecting the same force towards F1. So means you can say F12 is equal to F21. So equal in magnitude, the forces are equal in magnitude, opposite in direction, and this is act of two different bodies. This is not possible with single body. So for explaining Newton's third law, there must be at least two objects. Okay, next is how do you analyze the forces? Now till now we have studied about the forces, their analysis. Now first one is that no single force can exist in nature, as we can say as per Newton's third law. Second is forces always come in pair, means action reaction. Newton's third law is valid here. Third law. Okay, then third point is if body A exerts force B, then as denoted by FBA, then body B exerts force A, means denoted by FAB. तो उस केस में ये दोनों बराबर होंगे, FAB is equal to minus FB होगा. तो ये आपका न्यूटन थर्ड लॉ का, ये मैंने आपको एक्सप्लेनेशन बता दी. Okay, now important features of Newton's third law. What is important? One thing is it is having universal applicability. Okay, means Newton's third law applies to all types of forces with either mechanical, gravitational, magnetic, dielectric, etc. So Newton's third law is applicable to the entire universal. Applicability is there. Second is act on two different bodies, means action and reaction forces never act on the same body. Then if they did, अगर ऐसा होता तो क्या होता, they would cancel each other out and motion would be impossible. तो उस केस में motion possible नहीं होता. It means this Newton's third law is applicable to two different bodies. Third point is cannot cancel each other, means action and reaction forces do not cancel each other because they act on different objects. And final point is no action without reaction, means action and reactions are simultaneous. So if you are remembering all these points, so means you are perfect in Newton's third law. And while we are discussing more and more about this, you would find that the things are simple if you are able to understand it very easily. Okay, now see, law of conservation of linear momentum. Now what? Simple law of conservation of momentum means the total momentum of an isolated system, means no external force acting on it, and with constant mass, mind you, remains constant or conserved over time. So there are two important things. One is the constant mass is there, and this is the isolated system. So this means momentum does not change with time if no external force is applied. So this is very important thing. Okay, law of conservation of momentum is valid if there is no change, means there is no external force applied. So mathematical expression, what is mathematical expression? Let m1 m2 be the masses of two particles. For example, I'm just saying there are different particles. One particle number 1 hai, this is particle number 3. So basically all these particles are colliding with each other. So what happens in case of law of conservation of momentum, means p1 and p2 are the momenta of these particles, then the total momentum of the system is conserved, means p is equal to p1 plus p2, that is constant. So this is law of conservation of linear momentum. I think you get it. The net momentum stays the same before and after the interaction between the particles. As we move forward, we shall discuss about the numerical example, then it will be very easy for you to understand what the meaning of this law of conservation of momentum is. Okay, now see, there are two important things. You can easily understand this law of conservation of momentum as I just discussed. This principle basically directly follows from the Newton's second law, means rate of change of momentum, and Newton's third law means action has equal and opposite reaction. So law of conservation of momentum basically derives from Newton's laws itself. Okay, so real life example, you can say the two ice skaters pushing off each other move in opposite direction, but total momentum remains constant. Second is recoil of a gun when a bullet is fired. Okay, so these are certain real time examples, you can say. Now conservation of linear momentum for a system of two or more particles. उसके इसमें क्या होगा देखिए, force is applied on particle 1 by particle 2 is F12, जैसा मैंने आपको बताया, and force applied on particle 2 by particle 1 is F21. Okay, there are two forces and their respective momentums are P1 and P2. Then from Newton's second law we can say F12 is equal to ddt of P1, rate of change of momentum, and F21 is ddt of P2. Okay, then from Newton's third law F12 is equal to F21 with minus sign because every equal action has opposite reaction. So this dt of P1 is equal to minus of dt of P2. So we can simply infer from this like this, means dt of P1 plus dt of P2 is equal to 0, or you can say dt of P1 plus P2 is equal to 0. Finally we can say P1 plus P2 is constant. Okay, for n number of particles we can generalize this expression, means P1 plus P2 plus P3 plus up to so on. For n number of particles this is always constant. So this is what is the friends, this is nothing but the law of conservation of momentum. Okay, now conservation of linear momentum for the collision of two bodies, I just told you. So there are two possibilities. One is head on collision. Okay, means collision in a straight line. As you can see here, there is diagram. This is before collision. There are two different bodies having mass m1 and m2 with different velocities. Say u1 and u2 are basically moving in the same direction. Okay, now what happens according to Newton's third law? What happens? F12 is equal to F21 when the two bodies collide. As you can see in figure B, after time of collision, what happens? If the two are moving each other towards each other, then after the collision they will move backward. Okay, as you can see here, F12 and F2, these are the forces acting on opposite direction. So this is Newton's third law. Okay, then after collision these bodies movement remain conserved. How? This according to Newton's third law of motion, means F12 is equal to F21. Now F is basically m into v upon t, as I've just told you. Impulse momentum theorem अभी मैंने आपको जो बताया था उसके हिसाब से होगा m into a. तो a is rate of change of velocity, means m1 for body m1, you can say m1, and what is the change in velocity of this body m1, means v1 minus u1 upon t. v1 is final velocity, u1 is initial velocity. So v1 minus u1 upon t, this is the rate of change of velocity, means acceleration. And similarly for body number 2 with minus sign, m2 into v2 minus u2 upon t. So finally what we can say, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is simple derivation which shows the total momentum before collision remains same as total momentum after collision. So this is law of conservation of momentum. This is for head on collision, I just told you. Now oblique collision. What is oblique collision? collision example is simple, that collision of ball with ball. ठीक है, अब कोई दीवार पे आप बॉल फेंक के मारेंगे तो बॉल जो टकराती है दीवार से वो आपका oblique collision है. तो what is happening here? There is a oblique collision of ball with the wall. How it's happening? Suppose there is a ball striking with the ball at angle theta with respect to origin. Okay, the initial momentum is m into u1. Let the mass of the ball be m. Okay, it is striking with this ball at this point. Okay, after striking this, move backward like this, and final velocity is uf. So m into uf is the final momentum and m into ui is the initial momentum. So pi initial momentum and pf is final momentum. So we can see here. Okay, so this is this velocity is having two components. One is x direction and other is y direction. Okay, so this is minus m into u into sine theta in j direction because the one is striking like this. So if this is striking like this, it is having two components. One is this and another is this. Okay, इस तरीके से. Okay, so there are two components. This one is sine theta with negative sign and this is cos theta with positive sign. Okay, now this is mu cos theta in I direction. This is minus mu cos theta with because it would provide direction as per the Newton's third law. Every equal action is opposite direction. So this mu cos theta, this velocity would create opposite force in this direction. Okay, so ये मैंने यहाँ पे दिखाया है minus m into u to cos theta in I direction. Okay, so there are two different components of this velocity. So as we can see here, one is minus m into u into sine theta into j. So this is the y direction velocity and this is x direction velocity. Okay, so this is the collision of ball with wall. Okay, so what we can infer here that pi is equal to m u cos theta I minus m u sine theta j. देखिए see this one, फिर से मैं दिखा देता हूँ आपको. ये m u cos theta I और m u sin theta j. So there are two components. So finally we are adding these two. So initial momentum is m u cos theta I minus m u sin theta j. फाइनल मोमेंटम क्या होगा? पी एफ इज इक्वल टू माइनस एम यू cos theta I एंड माइनस एम यू sin theta j बिकॉज इन एक्स डायरेक्शन आफ्टर न्यूटन थर्ड लॉ एक्शन दिस वुड बी डायरेक्टेड इन द रिवर्स डायरेक्शन. तो ये साइन नेगेटिव हो गया. ये साइन तो पहले भी नेगेटिव अभी भी है बिकॉज वेलोसिटी ऑफ दिस बॉल इज स्ट्राइकिंग लाइक दिस. देखिए यहाँ पर देखिए ये फाइनल वेलोसिटी और ये इनिशियल वेलोसिटी माइनस वाई डायरेक्शन में ही है लेकिन एक्स डायरेक्शन वेलोसिटी अब रिवर्ट हो गई है. तो इन दैट केस आई एम जस्ट राइटिंग दिस नेगेटिव साइन. ओके, नाउ द चेंज इन मोमेंटम यू कैन से डेल्टा पी इज इक्वल टू पी एफ माइनस पी आई. Okay, if you are putting the values, you are getting this expression is means delta p is equal to minus 2 times mu into cos theta into I cap. So this is the expression which is change in momentum. Okay, so delta p is equal to 2 into u m into u into cos theta because I just told you this is delta p minus 2 mu cos theta I. If you are taking the mod means magnitude of this, so this negative sign would be removed and this I will also be removed because this is the unit vector x direction. So finally the magnitude of this delta p would be 2 into m into u into cos theta. Okay, then force is equal to delta p upon delta t as we know already. So this would be minus 2 m into u cos theta I vector I cap upon t. So you can say f is equal to 2 into mu cos theta upon t. So this is your force which is the magnitude of this force. Okay, now there are two possible cases. Now in this case there are two possible cases because if the ball is striking straight, okay, then theta is equal to 0 degree means ball is thrown perpendicular to the ball. Then delta p is equal to minus 2 m into cos 0 I because theta is 0. Then delta p is equal to minus 2 m into I. Then f is equal to delta p upon delta t gives me minus 2 mu upon t in I cap direction. Second case could be theta is the angle measured from the ball. Then you can say delta p is equal to minus 2 mu sin theta I. Now how this is possible? I just told you. Just let me show the diagram once again. This one. Now this time I am measuring the angle with respect to origin which is theta. Now if I see अभी मैंने यहाँ पर क्या कहा है? Theta is the angle measured from the wall. In that case this cos instead of this angle this would be theta. Okay, this is theta. In that case this would be sin theta. Fine. So this delta p accordingly would be changed, that is 2 mu into sin theta and accordingly जो cos होगा f में भी तो cos की जगह sin आ जाएगा. So this is how we can calculate the values of force and change in momentum as per the Newton's law. Okay, now next is forces in equilibrium, which is the simplified explanation here. I am just giving a simple expression how to understand this. Definition is when the resultant of all forces acting on an object is zero, the object does not change its motion. These forces are said to be in equilibrium. Okay, so in this state the object remains at rest or in uniform motion. Okay, due to inertia as we have already discussed, तो net force zero होगा. So such forces are called balance forces. मतलब balance forces are those which are neither creating the motion nor changing the state of any body. Means due to inertia the body will remain in the same condition as it is. Okay. Now what is resolution of force? Resolution का मतलब है हम उसको force को अपने different components में हम break कर देते हैं. So how to break a force? For example, if there is a force with respect to horizon at theta angle, then there would be two components. One is f1 and other is f2. Means one is horizontal and other is vertical component. As you can see. Okay. So with respect to theta, this vertical component would be f sin theta and horizontal component would be f cos theta. Okay, so yeah, f1 would be f cos theta, which is component of f along AC. AC is this one, horizontal direction, and f2 is equal to f sin theta, which is perpendicular to AC, or you can say along AB. AB is this direction, vertical direction. Okay, the component of a force in the direction perpendicular to itself is zero, right? अगर कोई force आपको already perpendicular तो उसका horizontal component already zero हो जाएगा, तो आपका single direction होगा, means okay. Now Newton's first law for forces in equilibrium. देखिए अब ये इंपॉर्टेंट है. अभी ये क्वेश्चंस we will be solving the problems based on these particular concepts. Okay. Now delta f is equal to 0. अभी मैं आपको लेमिथ थ्योरम बताऊंगा तो उसमें भी आपको ये चीज समझाएंगे. वो नेक्स्ट टॉपिक में हम डिस्कस करेंगे. Okay. Now delta f is equal to 0 means particle in equilibrium. We most often use this equation in component form. Means delta fx is equal to 0 and delta fy is equal to 0. If delta f is equal to 0 means the components of this in x direction as well as y direction would also be 0. तो उनका सम भी 0 होगा. तो इसलिए इसको this equation would be broken into two components. One is fx component and other is fy component. So you can say if there is z component also, then also you can decompose or resolve this component in this force in three components. Okay, just short back we discussed about the force components. Okay, so equilibrium under concurrent forces, that is those forces which act on the same particle at the same time, may be seen as like this. F1, F2. For example, in A, both are working in opposite direction. Similarly, you can say there are three forces F1, F2, F3. So these are different configuration, friends. These are three different configuration. You can have either of the configurations, okay, like this one, or this is the collinear, or you can say coplanar forces would be there, okay. So these forces would be added as per the laws. It could be a law, जैसे मैंने आपको वेक्टर में बताया था, it could be triangle law or a parallelogram law. So accordingly we can get the equation. For example, F1 plus F2 is equal to 0. Okay, in first case, in this case, what is the force equation? F1 plus F2 is equal to 0, because both the forces are equal and opposite. In this case, we are having three forces, F1 plus F2 plus F3. So similarly, in second figure also, F1 plus F2 plus F3. So on these two figures, F1 plus F2 plus F3 is equal to 0. So this is how we can calculate the Newton's first law for forces in equilibrium. Now further, if you move to the extension of these resultant forces, means algebraic sum of the forces, we move to Lami's theorem. What is Lami's theorem? Lami's theorem is simple, very simple theorem. It states that if you can say three forces acting on a particular, the forces could be more than three also. If the three forces acting on a particle are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Okay, if an object O is in equilibrium under three concurrent coplanar forces F1, F2, F3 as shown figure like this. Okay, there are F1, F2 and F3. Okay, now the question is these are the concurrent forces, means all the forces are working on the same body, and these are also coplanar. So these are two conditions which you should remember while applying Lami's theorem. So F1 upon sin alpha is equal to F2 upon sin beta and is equal to F3 upon sin gamma. Now what is F1? F1 is this force. Okay, now F1 force, this angle alpha, means for this force you just leap force, and what is the angle between other forces? Okay, the sine of that. Similarly F2 के लिए क्या करेंगे, इस फोर्स को छोड़ के बाकी जो एंगल है, फॉर एग्जांपल दिस इज बीटा, एंड सिमिलरली F3 के सामने जो एंगल है F3 के लिए काम हो गया. तो दिस इज द Lami's theorem. Okay, so now the next thing is, which is what are the common forces in mechanics. So there are basically four important things which you should study for solving the numerical problems of NEET examination. So for example, in this case we will be discussing four things. One is this weight, then normal reaction, you can say N or R, normally it is denoted by N or R, and then tension, and then spring force. Okay, so we will study all these forces one by one. Let us see. First one is weight. What is weight? The weight of an object is equal to the gravitational force with which the earth pulls it towards or downwards, you can say. The weight of the object is nothing but W is equal to mg, and you can say m is the mass of the object and g is the acceleration due to gravity. Generally g is 9.8 meter per second square, or for simplicity we take g is equal to 10 meter per second square. So this is about the weight. Next one is normal reaction, you can say. So it is a contact force between two surfaces in contact, which is always perpendicular to the surface in contact. The following diagram, just for example this one, you can say that show the normal reaction between the two surfaces. If suppose a body is put on a flat surface, this is the flat surface, then it would create a reaction force. For example, in this case, this body is having its own weight. Now due to its weight, it's reaction, it's creating a reaction, means in upward direction as well as downward direction. So there are two reactions. One is downward due to weight, and which is creating upward direction due to the reaction of this body weight. Okay. In this case also you can see, this is the example of normal reaction between two surfaces. For example, this is a wedge and this mass is put over this. Okay, if this mass is put on this, then what is the reaction? As you can see here, this is the kind of reaction, okay, which is provided by the mass, weight, and then reaction by this wedge. Okay, similarly for C, okay, there are two masses in contact and they are put on this particular surface, then there is a force. Then what is the reaction due to this force? The reaction between the two masses, as you can see here. So this is the reaction force because of this force. Okay, so these are certain examples of the normal reaction. Third one is tension. What is tension? When a body is connected through a string or rope, a force may act on the body by the string or rope due to the tendency of extension. This force is called tension. For example, in this case, suppose if I am pulling this body with certain force, so this creates a tension in that particular rope, pulley or rope. So this is called tension. Okay, so this is the third category of the reaction force. Now another example of this, for masses connected through string having same acceleration. For example, this, there are two masses connected through a string. This is the string, and they are having same acceleration A. Okay, for both bodies, and force is applied in this. Obviously, if the force is applied, the acceleration is in the same direction of the mass. Okay, so this string would be experiencing tension in this. Okay, tension. Okay, similarly in this is a pulley system, pulley rope system. These are two masses, small m and capital M. Okay, so one mass is moving upward and the mass is moving downward, depending on the weight of the mass, which one is greater. If this mass is heavier than the small mass, then this mass would be uplifted and this capital M would be downwards moving. Okay, so this is creating the tension in this particular rope. As you can see, this is a rope. Okay, so this would be experiencing tension in this. Okay, so don't worry, we will discussing the numerical problems right in this video. Okay, although this video would be a long video, but I will be explaining each and every concept in very simple and lucid way. Okay, there is another example of a string which is massless and there is no friction between the pulley and string. Okay, there is no friction between mass and pulley. So this is M and this is another capital M. Okay, so this would be experiencing a tension in opposite. Both the tension would be in opposite direction, because due to mass the tension in upward direction, and due to this pulley the down tension would be in downward direction. Similarly, between this small m and this pulley there would be tension in this string. Okay, so these are another examples. Okay, for example, this case also, string is massless and there is friction between string and pulley. If there is a friction, then also there would be a tension in this and this also. Okay, so this is basically example of now how these two are different. In one case it is frictionless, means no friction is there, and in second case there is a friction between the string and pulley. This means this tension would be changed, because in this case I'm saying this is T, but in this case there is a tension which is different from the earlier one, because in this case there is a friction between the pulley. But mind you, this tension would also be changing, because this is due to the tension in both the strings would be changing because of the friction present between the string and pulley. Okay, similarly third case is string is not massless and there is friction between pulley and string. अब देखिए यहाँ पर पुली और स्ट्रिंग के बीच में आ गया है, तो यहाँ पर भी आपके ये सारे वैल्यूज चेंज हो जाएंगे इस केस में, बट यहाँ पर चेंज हो जाएगा क्योंकि यहाँ पर क्या कहा है, इट इज नॉट मासलेस बट स्ट्रिंग इज नॉट मासलेस एंड देयर इज फ्रिक्शन बिटवीन पुली एंड स्ट्रिंग, तो ओनली दिस वुड बी चेंजिंग. तो विद रिस्पेक्ट टू फिगर नंबर बी, ओके, तो फिगर बी एंड सी आर सेम इन अ मैनर इन विच दिस स्ट्रिंग वुड बी एक्सपीरियंसिंग द सेम टेंशन. But since in this case this is not massless, then this tension would be changed. Instead of T2 this would be now T3 also. Okay, so I hope you are getting all these three examples. These are the minor differences, but you should understand what is the difference among these three examples. So mind you the differences, because we will be solving the numericals based on these particular concepts. Now fourth one is spring force. What is spring force? The resistive force developed in the spring when its length is changed is called spring force. Okay, spring force is nothing but F, which is minus K into X. Now X is the change in the length of the spring and K is the spring constant. This F is called the restoring force. Okay, so this is spring force. Simple. Okay, now see what is free body diagram. Today's last topic. What is free body diagram? A free body diagram is nothing but the diagram which consists of the diagrammatic representation of a single body or a subsystem of the body is isolated from its surroundings, showing all the forces acting on it. तो किसी भी बॉडी का आपको फ्री बॉडी डायग्राम बनाना है तो उस कंपोनेंट का डायग्राम बनाते हैं. फॉर एग्जांपल दिस मास इज पुट ऑन अ पर्टिकुलर ग्राउंड और किसी सरफेस पर रखा हुआ है, देन इफ यू वांट टू ड्रॉ द फ्री बॉडी डायग्राम यू हैव टू आइसोलेट दिस फ्रॉम द सिस्टम एंड देन ड्रॉ द रिएक्शन फोर्सेज, वेट एटसेट्रा और द फोर्सेज एक्टिंग ऑन दिस पर्टिकुलर मास. So this is what is the meaning of free body diagram. Means you are making the body free out of the system and then applying the forces or analyzing the forces. So this is free body diagram. So see, this is the topic. Now let us discuss the numerical problems on basis of what we have discussed till now. Now see friends, let us discuss some numerical problems about this particular topic. First one is, question 1 is, a bullet of mass 0.06 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted on the block on the bullet? Now S is 60 centimeters given, U is 90 meter per second square. Okay, retardation of bullet would be A is equal to minus U square upon 2. Okay, depending on this, now you can say A is equal to minus 90 into 90. You have just put the values, you are getting this. A is equal to minus 6750 meter per second square. So retarding force would be as per the Newton's third law. We have seen just F is equal to M into A. So M and putting the values M and A, you are getting F is equal to 405 newtons. Simple answer. Okay. Now these are drill problems. These are not so easy problems, but I am just making these problems easy so that it's very easy for you to understand these problems. Now the second problem is a force F is equal to 2T I plus 3T square J acts on the object moving in XY plane. Find magnitude of force change in momentum of the object in time interval t is equal to 0 to 2 seconds. Now it is simple, as we have already studied Newton's second law. Force is nothing but change in rate of change of momentum. F is given like this, dt of p is nothing but F, which is 2t I cap plus 3t square j. Now what is dp? Means change in momentum is nothing but you are integrating the equation on both sides. So means if you are integrating this equation, so integration would be nothing but 2 to taken out. As you can see here, simple integral 0 to t limit, because I am asking for 0 to 2 second. So for 0 to 2 second limit, you are just integrating these expression and finally putting the values. You are getting this delta p is equal to 4i plus 8j. So magnitude would be 4 square plus 8 square under root, that is under root 80, means around 9 kilogram into meter per second square. So this is change in momentum. Okay, so this is simple example. Now second one, next example is, or question is, let us consider two forces F1 and F2 acting on a body of mass 2 kg as shown in this diagram. Okay? F1 is 10 Newton and F2 is equal to 2 Newton. What would be the acceleration? So this is very simple. If you are just taking the forces in the direction as shown, you are getting the F resultant, that is 10 minus 2, because the two forces are equal and opposite, and the body would be moved in the direction of the greater force, means 10. So that is 8 Newton, means the F is equal to M into A. The acceleration would be F upon M, means 8 upon 2. You are getting 4 meter per second square. So this is nothing but the acceleration, and the body moves in the direction of F1 because F1 is greater than F2. Okay. Next is, a cricket ball of mass 150 grams is moving with a velocity of 12 meter per second and is hit by a bat, so that the ball is turned back with a velocity of 20 meter per second. If the duration of contact between the ball and bat is 0.01 second, find the impulse and average force exerted on the ball by the bat. Simple. This is simple. Ball mass is 150 grams. वेलोसिटी ऑफ बॉल इज 12 मीटर पर सेकंड. आफ्टर हिट बॉल की वेलोसिटी हो गई 20 मीटर पर सेकंड अपोजिट डायरेक्शन में. ओके, तो ड्यूरेशन ऑफ कॉन्टैक्ट इज 0.01 सेकंड. अब हमें क्या करना है, इंपल्स कैलकुलेट करना है और एवरेज फोर्स. नाउ डेल्टा पी इज इक्वल टू एम इनटू v minus u. Now what is m? 150 into 10 to the 3 ऐसा यूनिट में कन्वर्ट कर लीजिए, and this v is 20 minus of minus 12 because the ball is reverted back. So change in velocity is 20 minus minus 12. Okay, so this results in 4.8 Newton into second. This is the change in momentum. Now impulse is delta p Okay, so impulse is nothing but delta P, which is 4.8 Newton per second. Okay, or average force you can calculate, because this is being asked in the problem with FAB is equal to I upon delta T. That is delta P upon delta T. You can say 4.8 upon 0.01, because the time is time of contact is 0.01, as you can see here. So this answer would be 480 Newton. So this is the required answer. Next question is, two objects each of mass 5 kg are moving in the same straight line but in the opposite direction towards each other with the same speed of 3 meter per second. They stick to each other after collision. What will be the velocity of the combined object after collision? Right? Now how to solve this problem? See, m1 m2 both are same. u1 is 3 meter per second and u2 is equal to minus 3%. So this would be solved using the law of conservation of momentum. How to solve this? Just see, let the velocity of the combined object be, say, v, suppose. Okay, then you can say before collision and after collision. How to solve this? Means m1 into u1 plus m2 into u2 is equal to what? m1, you just put the value, you are getting 5 into 3 plus 5 into minus 3 is equal to 0, right? The total momentum of the body would be equal to, देखिए यहाँ पर मैंने सो लिखा m1v plus m2v is equal to m1 plus m2 into v, that is 5 plus 5 into v. फाइनल वेलोसिटी मैंने अज्यूम किया है v, तो 0 is equal to 10v, means you can say v is equal to 0. तो फाइनल मोमेंट ऑफ द बॉडी आफ्टर द collision would be equal to 0. So this is the solution for this question. Okay, next question is, a ball of mass m strikes a rigid wall with speed v and gets reflected without any loss of speed, as shown in the figure. See? Okay, as you can see here. Now what is happening? This angle is 30 degree. Now you have to calculate what is the magnitude of the impulse imparted to the ball by the wall. ये दीवार से इस पे बॉल पे कितना इम्पैक्ट है, अभी मैंने आपको एग्जांपल समझाया था. तो हाउ टू सॉल्व दिस? जस्ट सी दिस इज इनिशियल मोमेंटम, दिस इज द फाइनल मोमेंटम. ओके, इनिशियल मोमेंटम पी आई एंड फाइनल मोमेंटम इज पी एफ. तो हाउ टू सॉल्व दिस प्रॉब्लम? लेट अस सी दिस वन. तो देखिए यहाँ पर क्या है, इनिशियल मोमेंटम मेरा पी आई है, तो अकॉर्डिंग टू प्रॉब्लम मैं यहाँ कितना लिखूंगा, यहाँ पर इस केस में देखिए एम इंटू वी इंटू साइन 30. ओके, तो दिस वुड बी माइनस एम इंटू वी इंटू कॉस 30. ओके, दिस इज इन I direction and this is in j direction, as we have already discussed about this. Okay, this is pi, and similarly pf would be, see from this, pf would be equal to minus of mb sine of 30 I cap minus m into v into cos of 30 into j. Okay, therefore what is impulse? You can calculate the impulse value. Impulse कैसे आएगा यहाँ पर? Impulse would be nothing but delta p, that is pf minus p into I. Okay, तो this would be equal to minus 2 into, इसको आप दोनों को सॉल्व करेंगे तो कितना हो जाएगा, ये 2 minus 2 इंटू एम इंटू वी इंटू ये हो गया साइन 30 डिग्री इंटू आई. ओके, विच इज इक्वल टू माइनस सिंपल माइनस एम इंटू वी इंटू आई कैप. तो दिस इज द वैल्यू. नाउ व्हाट इज डेल्टा पी मॉड? इसका मैग्नीट्यूड कितना हुआ? ये दिस वुड बी सिंपली एम इंटू वी, लाइक दिस. So friend, this is the change in momentum. This is the answer first. Now second is, what is the direction of the force on the wall or due to the wall? See, the negative sign of the impulse shows that it is along negative x direction. Since the impulse and force are in the same direction, the force on the wall is along the negative direction of x-axis. Hence, the force on the wall will be along the positive x-axis. So this is the answer for this second. Okay, positive x direction. Now second is, an object is in equilibrium under, see this, 4 concurrent forces in the direction shown as in the figure. Find the magnitude of F1 and F2. Now these are 3 different forces or 4 different forces. According to Lami's theorem, we can solve this. How to solve this? Now see this one. This is very simple expression. Delta fx is equal to 0 and another expression is delta fy is equal to 0. So if you are decomposing all the forces in x component and y component, okay, because there are only 2 components. Okay, these are coplanar forces. Now object in x direction. So delta fx would result me, see this one, delta fx is equal to 0. If I am putting this, so this would be 8. All the forces I am considering 8 plus 4 into cos 60 minus f2. F2 is this one. So f2 cos 30 degree. Okay, so this is the x component. Okay, 8 plus 4 cos 60 minus f2 cos 30, and this f1 is concerned, means there is no horizontal component, means this x component of this is 0. So finally this is condition gives me the 0 value. Okay, or you can say using if you are solving this, so this would be equal to 8 plus 2 minus f2 into root 3 by 2, putting the values of cos 60 and cos 30 root 3 by 2 you are getting is equal to 0, means finally you can say f2 is equal to, this would be 20 upon root 3. Okay, similarly you can say, similarly delta f into y is equal to 0. What this delta f y is equal to 0 gives me, see this one, f1 plus 4 into sine 60 degree minus f2 into sine of 30 degree. Okay, this is equal to 0. Okay, so this would be giving me the value like this. So see, this f1 is equal to 4 upon root 3 Newton. So okay, so in order to save the time, I'm just putting the things in quite way. So this is would be simple, but the solution of this f1 is equal to this, and answer is required for f1. Okay, f1 and f2. So you have to calculate f1 and f2. So in this way you can calculate the values of the forces, right? Now next question is, see this one. One end of the string 0.5 meter long is fixed to a point A and the other end is fastened to a small object of weight n. 8 Newton. The object is pulled aside by a horizontal force F until it is 0.3 meter from the vertical through A. Find the magnitude of the tension T in the string and the force. Okay, like this. This, as per this diagram, you have to calculate the values. Now, how to solve this? See, this problem would be very simple if you are calculating the values in terms of the simple trigonometric way. How to solve this? Let us see this diagram. Theta, this is theta. Okay, now we can calculate cos theta first of all. Okay, simple. I am just making this simple problem. Cos theta would be nothing but, as per this AB, cos theta is equal to AB upon AC. Now, as per the question given, this AB upon AC is nothing but 0.4 upon 0.5, like this. So this would be 4 upon 5. Okay, right. Similarly, sin theta calculate कर लेते हैं. Sin theta would be equal to BC upon AC. So this would be simply 3 upon 5. Okay, so this cos theta and sin theta are evaluated. Now, using Lami's theorem. Okay, if you are putting Lami's theorem in picture, then what is the expression which is relating the three forces with each other? How to calculate this? Okay, so see this, F upon the opposite forces angle means sine of 180 minus theta. See this 180 minus theta is equal to another is 8 Newton. Okay, so this 8, for this 8 there are opposite angles means sine of 90 plus theta. Okay, this is sine of 90 plus theta. Okay, so this is sine of 90 plus theta, you can say. Okay, is equal to T. Now this is T. For 3, this angle is 90 degree. So this is simple sine of 90 degree. Okay, so I think you got it. F upon sine 180 minus theta, 8 upon sine 90 plus theta, and T upon sine 90. If you are solving this, you are getting F upon sine theta is equal to 8 upon cos theta is equal to T. Okay, so finally you are getting this T is equal to 8 upon cos theta. Okay, right. Now see this, how to solve this further. Now this would be equal to, if you are putting F cos theta is equal to 3 by 5, so you are getting T is equal to 10 newtons. Okay, now if T is equal to 10 newtons, then what is F? F is equal to nothing but F is equal to T sin theta, or you can say 8 sin theta upon cos theta. F is equal to 8 sin theta upon cos theta, right? See this one, F from this expression, F is equal to 8 sin theta upon cos theta, or simply T sin theta, you can say. So this would be, say, if you are solving this, putting the values means add into 3 by 5 for sin theta and 4 by 5 for cos theta. You are getting final answer is 6. Okay, Newton. So this is the answer for this particular problem. I think you get it. Okay. Now friends, see the next problem. 3 blocks A, B and C are placed one over the other as shown in the figure. Okay, three blocks. Draw free body diagram of all the 3 blocks. Okay, so for individual blocks, I'm just putting the body diagram like this. One is this block number A. So block number A creates a weight of its own. For example, this way. This is WA, right? And the reaction of this below wall means B block. This would be creating and this. Like, okay, so this is N1. So what is N1? N1 is the normal reaction between A and B. ये A और B के बीच में जो normal reaction हो वो N1 है. Okay, between A and B, right? Now second is this block B. Now block B, what block B means? The reaction means N1 reverted for this block A, and then what is the weight of this block B itself? That is block B, and for the reaction between B and C also there is a reaction like this. So N2 is nothing but the reaction between B and C, right? So this is free body diagram for block number B. Now for block number C, again N2 would be pairing with this one. Okay, so this is N2 as I just explained. Now the body weight of this block itself means WC, and the reaction from the normal surface जिस पे रखे होंगे उसका normal surface का reaction होगा. Okay, तो N3 क्या है? Between block C and the ground. ये ground है, इसके बीच में reaction हो. तो this is the answer for the problem. Okay. Next problem देख लेते हैं. A block of mass M is attached with 2 strings as shown इन द फिगर. ड्रॉ द फ्री बॉडी डायग्राम ऑफ द ब्लॉक. तो देखिए यहाँ पर इसको किस तरीके से करेंगे. यहाँ पर ये सिंपल एक्सप्रेशन बना हुआ है, तो इसका फ्री बॉडी डायग्राम कैसे बनेगा. सी दिस ब्लॉक is separated from the system. Now there are forces acting on this force. Now how to show this? See, this one will be having 2. One is this one, T1, because this is T1. As you can see here, this is T1, right? This is T1, tension in string. Now there are 2 components of this string. Suppose this is theta, then this would be T cos theta or T1 cos theta, and this would be equal to, see this one. This one is T1 into sin theta, right? Now what about this? इस सिस्टम में भी टेंशन होगा, इसको मैंने T2 बोल दिया. लेट इट बी T2. ओके, लेट इट बी T2. एंड बिसाइड दिस द मास और द वेट, रादर वेट ऑफ दिस विच इज m into g. बिकॉज इसका अगर मैं मास इसका इफ आई एम अज्यूमिंग द मास टू बी m kg, देन ड्यू टू ग्रेविटी दिस वुड बी एक्सपीरियंस अ weight toward downwards. Okay, so this is the free body diagram of this particular question. All right, now see the next question. What is the question? All the surfaces are smooth in following figure. Find f such that the block remains stationary with respect to wedges. Now, देखिए दोस्तों, ये इस क्वेश्चन करने के 2 तरीके हैं. एक तो इसको इसको इनर्शियल फ्रेम ऑफ रेफरेंस के तरीके से कर सकते हैं. दूसरा तरीका इसका नॉन डिफरेंशियल फ्रेम ऑफ रेफरेंस से भी करते हैं, मतलब ग्राउंड के रेस्पेक्ट में करते हैं. तो अभी मैं इसमें आपको बताता हूँ एक मेथड, ठीक है, विच इज नथिंग बट फ्रॉम इनर्शियल फ्रेम ऑफ रेफरेंस. हाउ टू सॉल्व दिस? तो इसमें आपको इसका एक तो फ्री बॉडी डायग्राम बनाना पड़ेगा. ओके, तो इसका फ्री बॉडी डायग्राम बनाने के लिए क्या करेंगे, देखिए यहाँ से एक मैंने यहाँ सपोज ये मैंने इसको इस तरीके से इस पर्टिकुलर वेज के लिए मैंने इसके डिफरेंट फोर्सेज को हमने यहाँ पर ड्रॉ कर लिया है. दिस इज एन साइन थीटा बिकॉज दिस एंगल इज थीटा, तो दिस इज एन साइन थीटा. ओके, नॉर्मल रिएक्शन इज सपोज एन एंड दिस वुड बी एम इंटू जी, राइट, एंड दिस वुड बी एन कॉस थीटा, माइंड यू, एन कॉस थीटा. ओके, बिकॉज दिस इज स्लांटेड वेज है ये. ओके, तो एक्स वाई मैंने डायरेक्शन ऑलरेडी दिखा रखे हैं. तो देयरफॉर यू कैन से एफ वाई सिग्मा एफ वाई इज इक्वल टू 0 बिकॉज आई एम सॉल्विंग दिस प्रॉब्लम यूजिंग इनर्शियल, मैं लिख देता हूँ इनर्शियल फ्रेम ऑफ रेफरेंस, मतलब यहाँ ग्राउंड के रेस्पेक्ट में कर रहा हूँ मैं. ओके, तो सिग्मा एफ वाई इज इक्वल टू 0 इफ आई एम पुटिंग, आई एम जस्ट सॉल्विंग द माई प्रॉब्लम. हाउ टू सॉल्व दिस प्रॉब्लम? सी दिस, sigma fi is equal to 0, then decomposing the forces like this. So this implies sigma fi gives me n into cos theta because this is in the y direction. N into cos theta would be equal to m into g because this is a weight in downward direction for this particular diagram because the force is acting on this in this way. Okay, so this is one equation. Now sigma fx similarly would be equal to 0. Okay, now sigma fx is equal to 0 gives me n into sin theta. See from this diagram, in x direction n into sin theta is equal to m into a because force is applied in this direction, so this would be accelerating the motion in this direction. Okay, so both n sin theta and m are in same matlab in the same direction, so you can say n sin theta is equal to m into a. Okay, so this is equation number 2. Now if you are equating the two equations, equation 1 and 2, you can say a is equal to, you can say with the help of these two equations you can say a is equal to g tan theta. Okay, therefore f, this implies f is equal to m plus m because m is the mass of wedge and small m is the mass of this block which is put on this. So for the condition is that block remains stationary with respect to wedge. How to solve this? Now this, see this one, f is equal to m plus m into a. Okay, and instead of a I am putting m plus m into g tan theta, right? Now this is m is equal to m plus a g tan theta. Okay, so for this must be the force. तो क्वेश्चन का आंसर ये हो जाएगा, ऑल द सरफेसेस आर स्मूथ इन फॉलोइंग सर्फेस, f would be equal to m plus m into g tan theta so that the block remains stationary with respect to ground. तो this is the solution for this particular question. this इसका एक alternate method और है which is non inertial frame of reference. वो मैं आपको किसी नेक्स्ट एग्जांपल में बता दूंगा. ओके, फॉर एग्जांपल दिस वन, a bob of mass m is suspended from the ceiling of a train moving with the acceleration of a as shown in the figure. Find the angle theta in equilibrium position. अब देखिए इसको कैसे सॉल्व करेंगे, हाउ टू सॉल्व दिस प्रॉब्लम. तो अगेन दिस इज द प्रॉब्लम विच कैन बी सॉल्व यूजिंग बोथ द मेथड्स, नॉन इनर्शियल फ्रेम ऑफ रेफरेंस और यू कैन से इनर्शियल फ्रेम ऑफ रेफरेंस. दोनों मेथड से आप इस प्रॉब्लम को सॉल्व कर सकते हैं. तो चलिए मैं इन दिस पर्टिकुलर केस आई विल बी यूजिंग नॉन इनर्शियल फ्रेम ऑफ रेफरेंस. तो लेट अस सॉल्व दिस यूजिंग नॉन इनर्शियल फ्रेम ऑफ रेफरेंस. मैंने लिख भी दिया है, तो ट्रेन के रेस्पेक्ट में हम करेंगे. तो हाउ टू ड्रॉ फ्री बॉडी डायग्राम ऑफ ट्रेन or rather bob with respect to train, how to draw. So see this one, see for this particular diagram how to solve this. Suppose this is the bob. Okay, so there would be a weight factor like this mg, see this one, and this would be because force acceleration in this direction, so this would be f is equal to m into a. Okay, now this bob would be creating a tension in the string also, so this would be tension in the string with respect to this horizontal, this angle is theta, so this angle is also equal to theta. Okay, now you decompose or rather resolve these components. तो इसके चार components हो जाएंगे. as we can see this would be mg as usual जैसे यहाँ पर है. Okay, but this would be t sin theta for this angle, this would be t sin theta and this would be t cos theta and this is basically m into a. Okay, so again sigma fx is equal to 0 would get me f in t into sin theta is equal to m into a, right? Equation number 1, right? Similarly sigma fy is equal to 0 would get me the value of say this y component with t cos theta is equal to m into g. This is equation number 2. Now again using these two equations you can get the value of theta. Okay, because I am interested in the value of theta. तो theta की वैल्यू क्या होगी यहाँ पर? Theta would be equal to nothing but tan inverse a upon g. If you are dividing the two equations 1 and 2, you are getting theta is equal to tan inverse a upon g. So for this particular problem the theta should be tan inverse a upon g for equilibrium position. So this is the answer. मैंने आपको दोनों मेथड बता दिए थे कि previous example I was discussing about inertial frame of reference and now in this problem I am just talking about non inertial frame of reference. तो दोस्तों this was the video for today and just get me the feedback. How did you like the video? And in the next part I will be discussing the remaining topics of this laws of motion, and in third part also we will be discussing the lot many of blasting PYQs. Okay, so just wait for those two videos. I will be putting my best efforts in solving those problems so that you are getting the benefit from my videos. Thank you for watching my video and stay healthy, stay busy. Jai Shri Ram.